This is Trig Identities Part 3. I will be doing these 5 problems, and I will probably also make a Part 4. Okay. Well, here we have 1 minus this whole bit. This whole bit equals sine theta. Okay, so I know definitely I'm not going to do anything with this side here because it's already simplified. So I need to simplify this side, and I can't simplify the 1. So what I'm going to do is I'm going to write cosine as 1 minus sine squared. So I have 1 minus sine squared over 1 plus sine, which equals 1 minus, and I'm going to break this up as, I'm going to use the a squared minus b squared formula. And I'm going to break this up as 1 minus sine times 1 plus sine, all over 1 plus sine. Now from here I can simplify and cross these two out. So what I'm left with is 1 minus 1 minus sine, which is 1 minus 1 plus sine, which is 0 plus sine, which gives me sine. So I have my two sides equaling theta, theta, these two sides equal. Okay, basically I used my identities and I used my factoring facts. A minus b times a plus b. Okay, and this one, we want cotan. Basically both sides, it wouldn't really matter what side you worked with on this one. I know I don't want to change this in terms of sine and cosine, mainly because my answers over on this side are cotan. So I'm going to rewrite this in terms of cotan. And so I'm going to rewrite this. Come on, work. Tan, we know, equals 1 over cotan, based on your identities, and that's what I'm going to do. I have 1 plus 1 over cotan over 1 minus 1 over cotan. Now I'm going to take each piece and write it with a common denominator. So my numerator, my common denominator is cotan. So I get 1, or cotan plus 1, because this is over 1. And here it's going to be cotan minus 1 over cotan. I know these two cancel out, and so I'm left with cotan plus 1 over cotan minus 1. So they match. Okay, I thought I was going to need more room for that. I don't, so here we go. Alright. This one is pretty simplistic on this side. I might want to just look at this and know that this is really 2 times what? Sine over cosine. So it's just 2 of these, and I already have 1 here. So what I'm going to probably do is just work with this right here, rewrite this in terms of sine and cosine. So rewrite with sine and cosine. So we know this is 1 over cosine, and this one is 1 over sine. And if I do my little 4th grade math here, this 1 over cosine divided by 1 over sine is the same as saying 1 over cosine times sine over 1, which gives me sine over cosine. Now I'm going to bring this one down, so that's plus sine over cosine. I have 2 of these, so I'm just going to write it as 2 times sine over cosine. So if you simplified this side, you can write it as, you can keep it like this, since both sides match. Or if you didn't do this, you could then take this one, and write it as 2 tan theta, and these two would have matched. Okay, 55. Okay, so by now you should know that this is already simplified, and it's in terms of sine and cosine. So what I'm going to do is I'm going to look at these two and write these in terms of sine and cosine, and clean this up. So I'm going to have cosine over 1 minus sine over cosine plus sine over 1 minus cosine over sine. I'm going to write these over a common denominator. I'm going to clean this side up. So this is going to be cosine over cosine minus sine over cosine plus sine over sine minus cosine over sine. Now if you do the division on this, I'll just do one of them. This is cosine times cosine over cosine minus sine. So we get cosine squared over cosine minus sine plus sine squared over sine minus cosine. Okay. Oh. And in this case, what I'm going to do, I'm going to see what the best way to do this one would be. Write this in terms of, this is where we're going to need to do a little remedial stuff. I can make this a negative here. If I do both negatives here, I will get on the top cosine squared minus sine squared. And then this will flip, and this will be cosine minus sine. So I can write this as cosine minus sine here. So we have basically cosine squared minus sine squared over, what was it? Okay, cosine minus sine. Now I know that this follows the form of a squared minus b squared. So I'm going to write this as cosine minus sine times cosine plus sine all over cosine minus sine. So this crosses out, and we're left with cosine plus sine. So it matches to the original. Okay. Again, this side is pretty simplistic already, So I'm going to write everything in terms of cosine and sine. The numerator here is going to be sine over cosine minus cosine over sine, all over sine over cosine plus cosine over sine. If I have the same denominator, which would be cosine sine, I'm going to get sine squared minus cosine squared. This is just following your what times cosine gives you sine, cosine sine, and it's sine, so sine times sine is sine squared. And the same thing follows for the denominator. We're going to get sine squared plus cosine squared over cosine sine, And when you have something like this, this equals, this cancels, this equals 1. So we have sine squared minus cosine squared over 1. This equals, I need sine squared, right? So what I'm going to do in this case, I'm going to rewrite this. Let me do this in red. I'm going to restart again. I'm going to do sine squared minus cosine squared. And I really need 2 sinus squared of theta. So I'm going to rewrite this as 1 minus sine squared. So we get sine squared minus 1 plus sine squared. And that leaves us with 2 sine squared minus 1. So obviously I did something wrong. Okay, so we get sine squared. And I think I'm doing something wrong, but what I forgot, and I'll go back to the original, what am I forgetting here? The plus 1. So I'm going to add the plus 1. And what happens here is the 1's cancel, and you get 2 sine squared theta equals 2 sine squared theta. Okay. Now I know we've been going over these very quickly, and I know this one was a complicated one, especially when we got to the common denominator. So make sure you know how to do the common denominator, and you divide by now. I also want to go over very quickly something that we went over earlier. When you have something like, let's say we had, what can I do? 1 over x minus 2 plus, let's say 3 over 2 minus x. You know that if I put a negative in front of this one here, 2 minus x, I'm going to get negative 2 plus x, which is the same as x minus 2. And sometimes when you want the same denominator, as long as you make, if you multiply these both by negative, you can do that. So if I want this to have the same denominator here, I'm going to do 1 over x minus 2, and I'm going to change this to x minus 2, but I have to change this to a negative. So I would have 1 minus 3 over x minus 2. So note to self, to me, I need to go over this as a warm-up in class. Okay.